This conference will now be recorded.
Hello, everyone, and welcome to this week's Satellite Book Club Seminar Series. Brian Gockel here, Office of Observations. Title of our talk today is Lightning Imaging Sensor LIS Data in AWIPS. Our presenters today will be Scott Lindstrom from SIMS, Lee Cronch from SIMS, Chris White from WFO Huntsville, and Steve Goodman, if he's able to join us from the GOES program office. Reminders, as usual, this session is being recorded. We encourage attendees to post their questions in the chat room, and we'll field them from there in a Q&A session. Most of you are already doing this, but as always, please sign in with your full name so we can follow up with you if needed. We are always looking for presenters for future Satellite Book Club seminar series. Looks like we're mostly lined up for the next 6-8 weeks or so, but we're always planning ahead. So if you are interested and have a topic you'd like to share, please contact the TRMM team. And if you need any assistance developing materials, please contact Brian Mata. He and the training team can provide guidance and direction and perhaps assistance with that. Thanks as always to the TRMM team, Kashad, Lee, and Tristan, and their colleagues. Office of the Chief Learning Officer, GOES program, JPSS program, and to our speakers and participants. A few introductions about our speakers today. Scott Lindstrom grew up about a mile from Penn State Meteorology Building, eventually receiving 2 BS degrees from Penn State, and then went on to graduate school at the University of Wisconsin at Madison, where both of his parents and all 4 grandparents graduated as well. Scott creates training documents, quick guides, blog posts, and visit training in collaboration with FDTD and the Weather Service. Chris White has also served in the role of Applications Integration Meteorologist, AIM, Applications Integration Meteorologist, I should say, a position between the Weather Service and NASA Sport down in Huntsville since August 2011. As the AIM, Chris helps researchers at Sport develop, test, and transition experimental products to the Weather Service and it's to its forecasters and collaborative offices across the CONUS and the OCONUS, while also occasionally taking rotating shifts as the lead forecaster at Huntsville. Lee Cronch has been working with SIMS since 2008 and has supported the development and integration of new products within the AWIPS software framework. He also provides assistance to many projects focusing on severe weather, air quality, turbulence, and in situ observational platforms. Lee, welcome to the Satellite Book Club. Scott and Chris, welcome back to the Satellite Book Club. Please take the mic and we're ready for your presentation as soon as you're ready to begin.
Thanks, Brian. I hope you all can hear me. Steve Goodman is actually on a plane back from Darmstadt, so he is not going to be joining us today. So this is a project that was pushed by Steve, I would say. So he had this idea to get this data into AWIPS, and this is kind of showing you what we've done. So the LIS is the Lightning Imaging Sensor. As you see here, it flies on the International Space Station, and it's the same kind of sensor that was on the TRMM. So you can think of it as augmenting or extending those TRMM observations of lightning. It has 4-kilometer resolution. Compare that to the 8-kilometer resolution on GOES-R, and think about how the resolution on GOES-R might be degrading away from nadir. Doesn't quite degrade so far from the LIS because you never get quite that far away from nadir. And it gives you global data, so it can provide data to any national weather forecast offices that don't fall under the GOES East or GOES West umbrella, or for regions that have responsibilities that are outside the GOES East and GOES West umbrella. So of course, it's a polar orbiter, so not quite a polar orbiter. It's not geostationary. So the first question probably people will ask is, well, where's the ISS right now? And of course, there's a website for that. So you do a web search on where's the ISS. I mean, at least in my, I've done this so often that at least in my web browsers, it comes up right ahead. You have a website that looks like this, where you have where is the ISS right now and where has it been in the last hour and a half and where will it be in the next hour and a half. So it's not quite the same as, I can say I haven't used the ISS enough that I know kind of intuitively where it is. I still do have to look it up. So it's different from NOAA 20 in that aspect, where I kind of know where NOAA 20 is right now. I don't know where the ISS is right now. Actually, I do because I just looked. So the motivation for this is that the LIS has good observations that do complement what GOES 16, 17, and soon to be 18 GLMs will show as well. And like I said, LIS is giving you global data. There are regions where GOES 16 and 17 detection efficiency from the GLM fall off. So the first thing Steve was really curious about, I think, was can you use LIS in those regions where GLM might not be giving you great observation? So that's kind of the impetus behind this kind of study. And also, it's always fun to look at new data. So here's kind of the motivation. These are comparisons of detection efficiency over the GOES 16 footprint. That's that black dashed line. And it's compared to the Earth networks, the GLD 360 and the LIS from left to right respectively. And you're seeing that the LIS is giving you observations in a region where the GLM might not be having great detection efficiency, specifically over, say northwest, to the northwest of, in the northwestern part of the United States. I like to think, in the Glasgow forecast office, because Glasgow has bad satellite coverage, and the detection efficiency of the detection efficiency of GLM falls off as you get up around Glasgow. So it is complementary to the GLM. So over half the globe is not viewed by GLM. So if you want observations in the forecast office in Guam, for example, great National Weather Service forecast office where the day begins, you don't have GLM data there, but you could have LIS data from ISS. So it can give you total lightning information in regions where you don't have GLM. And it has higher resolution. So you have a better chance of viewing very, I'm not sure what a good adjective here is for lightning, for very minor lightning strokes. It's not minor until it hits you, but you have better, you are better able to detect weak lightning with the ISS LIS than you are with GLM. So I'm going to have Lee Krantz talk to this part because this is work that he's done. So take it away, Lee, and I'll just step forward in time.
Okay. So I was tasked with getting this LIS data into AWIPS for GLM comparison purposes to see where the LIS data can benefit over where we may not have the GLM data. So just a little bit about the data themselves. The lightning event data from LIS, they're data sparse. So not every file is going to have data in it for lightning events because it just didn't exist at the time frame that file is valid for. But it's also just not mapped to any sort of grid or satellite projections. So therefore, we couldn't apply this product into the standard kind of TowerS plugins that are available to us, which is either kind of the SCMI data plugin or the satellite point set plugin, because again, as I said, there are no, these data aren't gridded, and they're not mapped to a specific satellite projection. So they're just instead individual lat-long points. So we needed to figure out a plugin that would actually work for this. Well, speaking with Lee Byerly, in the past, we've tried to use DBGeo from the TowerS group, which should support this type of data, but this one has some sort of nuances within the code that lead to extremely long rendering periods. So it really downplays the use of any sort of product using that particular plugin. So what was suggested was to use the derived motion winds plugin for AWIPS as a suggested workaround for this issue, as it can handle individual point data. There's just some configuration that is involved with that in order to get it into your AWIPS system. Go to the next slide, please. So to prepare the data for the plugin, there's a couple additions that need to be made to the LIS data files that the DMW plugin is actually looking for. So there's a little pre-processing script when we get the data via LDM. It takes the data, adds the necessary fields that are needed for this file following the LDM receipt, and then it adds those in, which is a data quality flag and an arbitrary band number flag that DMW is looking for. Once it's done, there's just other simple files that need to be added for configuration. So we're looking at the distribution file for the DMW plugin, a description of the data, and then a menu and bundle file just so we can actually access the data within the CAVE framework, and then some SVG configurations for displaying the graphical rendering, the dots that you see on the screen. The data themselves are not stored physically, or not, I shouldn't say physically, but they're not stored in the AWIPS HDF5 repository. They're actually just strictly stored in the PostgreSQL database for AWIPS. And as I said, not all the files contain lightning events, so that was necessary to have that Python script in there, the pre-processing script. I do have this AWIPS configuration recipe available. If anybody's interested in getting it, they just need to contact me. And the data themselves are acquired from NASA NSSTC and UAH via LDM. The data is 20-second resolution, and the files themselves that you would receive are 2-minute aggregate files of that 20-second resolution data.
Okay, thanks, Lee. Thanks, Lee. So comparing LIS and GLM is a little bit of a challenge because when you look, I don't have flash points from GLM, but that's essentially, I think, what the LIS observations are giving you. So we have these, you're comparing similar things, but they're not quite the same. So it's hard to compare a flash extent density, for example, to an LIS flash. So as I say, making direct comparisons a challenge. But I do have some examples to show you. So this is one of the reasons for doing this, and this is showing the flash events from LIS in yellow. You'll notice these are all the same time, 7:18 UTC on May 20th, 2020, and also flash extent and density from GLM up over Montana, and you'll notice a flash event from LIS that doesn't seem to have any correspondence to the flash extent density in GLM. So for lightning awareness, you want to have as many good observations as possible. This might be one where the lightning event just wasn't intense enough over Montana there for the GLM to detect it. And this is a nighttime, so in principle, when the detection efficiency of the GLM is going to be most impressive. So this is from a poster that Steve Goodman had at the CMM meeting here in Madison sometime this past summer. So here we have another example. So we have lots, you'll notice how the times aren't really changing very much, but there are lots of different flashes. So the flash events in the LIS are really interesting because they're coming very frequently. And so I've overlaid them on top of the flash extent density here, and you see a pretty good correlation, I think. It's always hard for me when I'm looking at this to determine, where is the LIS not seeing lightning because it's outside of where the orbit is. And that's kind of hard to tell. So that region up off the coast of South Carolina, I don't see a lot of flashes there. And I'm not sure if it's because the LIS isn't up there yet. So that's a perpetual problem with this. And then we also have this region where there's a big flash extent density. This is 5-minute data though, so maybe all of those flashes were happening before the LIS showed up. So trying to compare these two fields, you really have to think about exactly what you're seeing. So the LIS are looking at individual events, and then you're comparing these to average events over 5 minutes. So you'll naturally have some kind of variability. So here we have it compared to the flash extent density. I also have it compared to the band 13 here. So I changed the color of things, but you see that there's that region where there were no lightning events that I circled. That was right over here to the east-southeast of Miami. And again, I don't know if it's because the LIS is not, is that within the field of view of the LIS? I'm not certain. So, one day in September, I went to the Where is the ISS website, and I'm seeing it's overflying Typhoon Hinamnor up to the northeast of, or to the east of Taiwan. I think it is just about ready to start its acceleration off to the northeast. And I thought, well, that's kind of cool. So we have all these LIS observations to the western part of the storm. So this is over the target sector of Himawari 8 band 13 imagery. Again, showing you how you might be able to use this to get an idea of exactly where there might be the most lightning in this particular typhoon. So you notice there's really nothing in the eye wall here. Again, I can't say that that's because there's no lightning there, or if it's because the LIS isn't viewing that part of the storm. So I still have to figure out a way to, maybe shade on the shade, put a shading in here that says this is the orbit. This is where the LIS has a possible, this is where the LIS just might be able to see things. And I think that's all I have. I just wanted to show you what you can do with this LIS information once you get into AWIPS. All our emails are here. And that's, I told Kashad and Lee that we wouldn't have a very long presentation here. So there's plenty of time for discussion. I hope there are lots of questions, that this is information you can use. So thank you.
All right, thank you, Scott and Lee and Chris. We appreciate this, this briefing. And as usual, we're going to get to Q&A in just a second. So please do. I see questions starting to come in. Questions, comment. Please put your questions and comment in the chat, and we'll field them from there. And we're particularly encouraging feedback from field staff and regional headquarters staff, folks close to the Weather Service field offices, as we want to prioritize those questions. So just a couple quick reminders before we get to the Q&A. We've got a session a week from today. Gabrielle Brown, former intern at WFO Columbia, South Carolina, will be discussing GLM lightning trends prior to tornadoes associated with U.S. landfalling tropical cyclones. So continuing on the lightning theme next week. Want to point out we'll be starting 30 minutes later than usual, 30 minutes past the top of the hour for those joining next week. We're at a slightly shifted time. Want to remind everyone to contact the TRS team, Lee Byerly and Kashad Bowman, for questions about the Satellite Book Club or for configuration of satellite products. So we're going to get to questions here. I'm going to start with one and a few comments, and we will get right into the questions posted there in the chat. We interested in the live tracking of the ISS website, telling us where the ISS is now. Chris, thank you for posting the link into the chat. Check it out if you haven't already. We wanted to tell you the TRS team here has been thinking about and maybe looking into a similar utility to tie together all of the non-geostationary satellites. We know there are websites out there like this one, and they're tremendously helpful, but it would be even more beneficial if something could be a little more closely integrated with AWIPS to allow users to see all those commonly used satellites maybe in one place. So I don't think we're ready to quite make a commitment on that yet, but the team has been thinking about that, and maybe we'll have something to talk about in the not too distant future. Another question is, and I'm sorry if this was in the slides, but what is the range of latency that interested users might expect of the LIS data? And that is, how much time would typically elapse, or what is the range of times that would elapse between when the space station flyover is and when the data set would be available to the forecaster on an AWIPS workstation? And any of the speakers, feel free to comment on that if you could.
Yeah, maybe that's a best question answered by Lee, but it's my impression that once it's there, it's really quite quick. I mean, it's under 5 minutes. So it shows up in the amount of processing is not extensive. So it shows up, I mean, it's not as fast as GLM, but it's very fast. Yeah. I haven't really looked at it because it's never really, I mean, I'm never really looking at it as it's coming over, because I think, oh, where's the ISS now? And I'll go look at it, and it's someplace else, and I'll look at something from the past, but I don't think it's more than 10 minutes.
Okay, very good.
I can add,
go ahead.
Sorry, Brian. I can add in that Scott's correct that the processing time is very, very fast. I personally do not know, as soon as we receive it from the LDM, it gets processed immediately, and it's pun intended, it's lightning fast, but aside from that, I do not know what the downlink time is and what the processing times are for. That would have to be answered by somebody at an SSTC for that particular information.
Okay, very good. I suppose we could also do an analysis just based on if we have a direct feed to that site, we could kind of measure it just by understanding when the data become available on LDM. Anyway, thanks for those responses. If I could jump into some audience questions now, participant question. Chris Strong asked, do the LIS ISS data exhibit parallax issues?
Issues. Well,
Check.
Yes, there is going to be parallax in the ISS data, because it's going to be, I mean, because it's, depending on where the lightning is occurring in the cloud and where it's being georeferenced, there's going to be some shift. But because this is from a non-geostationary satellite, I think the parallax shifts will be a little bit smaller. Of course, you're going to have to know which side of the view you're on to know which way the parallax shift is occurring. So yes, there is a parallax shift, but it's not going to be constant, and it's not going to be as great as it is with GLM. I mean, not being constant, that's the worst part, because you don't know exactly which direction it should be shifted.
Mm-hmm. Yeah, and we face similar challenges with some of the polar orbiting data where it's not always obvious where the data observation is relative to the center of the orbit.
Right, especially with microwave data, yeah, especially.
Yep. Another question from Dale Zhang, and I apologize if I'm mispronouncing names today. The question is, the ISS LIS archive data at GHRC are non-QC'd since October 2020. Is there any plan to process the QC'd files and feed in the QC files, the QC'd files?
This is something that Steve Goodman might know the answer to. So I would email Steve and ask that question because I don't know.
Okay, could I ask if the TerraS team here will take that action to follow up and maybe publicize the answer in the notes that when we post this session. Any other thoughts on that question?
Hey, this is Chris, if you can hear me.
We can.
Yep.
Yeah, it'd probably be important to know, I guess, when the QC process, what is the added latency to the data set, and then whether or not that makes it viable for operational applications, but that's something that we would have to, explore.
Okay, very good. I'm going to move on to the next question from Joseph Patton. Any ideas for how to visualize the LIS field of view? I think you can have an updating location of the ISS and then draw a range ring around that point, updating every minute or say every 5 minutes. Any thoughts on that?
I think this is Lee. I think that's a possibility. It could be updated. There could be some sort of range ring that's set on there for the actual location, because I think the location of the International Space Station is within the data files itself. So that's definitely something that could be doable.
Hey, this is Chris again. If I could speak to this issue too. Yeah, I think especially because of the nature of the data and it being well, not necessarily polar orbiting swaths, but it's it's not geostationary, and there's no associated imagery with it like there would be polar orbiters. You don't know what the edges of the bounds are in that issue that Scott pointed out, and so I think if it's going to be something that's going to be used operationally for forecasters, it would be good to know what are those domains. And I can say that there are other sorts of GIS compatible or like GeoTIFF sorts of files that you can bring into AWIPS. There's like the fire perimeter files that are brought in daily now. We're actually working at SPOR on a way to deliver what are VIIRS and NOAA 20, essentially NOAA 20 swath widths into AWIPS via GIS sort of compatible files. So I think that something like that would be necessary and probably useful for this sort of data set.
Agreed. Other thoughts on that before we move on to the next question? And if not, we've got another question from Dale. Have you considered use of implementing the field of view? And there's a link in the chat. Looks like it points to a Pi Lightning plotted background web page. I'm not familiar with that, but can someone speak to that?
I'm also unfamiliar with that site that I've just clicked on for the first time in my life. That does look useful. The challenge is getting something like that into AWIPS, I think, because if you're going to be using these data in AWIPS, you do want something like that that says where, what are,
Yeah, there would have to be some sort of, associated data that come with it in order to make those kind of those little kind of postage stamp images along with the lightning data. Now, it's a possibility because Python is built into AWIPS as well, or I should say AWIPS uses Python under the hood for derived parameters and things of that sort. So it's something that's definitely possible, but there would have to be that additional data, whether it's pulled from actual viz data that's already there for the satellite data or something of the like. But it's always a possibility. That is definitely an option because that is Python based.
Okay, other thoughts on that? And we see Lee followed up in the chat with an answer to our earlier question of the latency. He's reporting 2 to 3 minute latency between the data valid time and the time received via LDM. So that's quite good considering.
So it is lightning fast.
Yes, it is. Considering there are probably several relays involved. In some cases, at least, depending upon where it is. Okay, then we'll move on to the next question, which I think is a question and an answer. Thanks, Sheldon, for the question was, for those who don't have an AWIPS, is there a way to see ISS lightning, either past or current, from the internet? And Sheldon responds with a website. He's got the link there. Feel free to click on it. It looks like it's being updated in real time. So for non-AWIPS users, it looks like there is a source for at least a visualization. Thanks, Sheldon, for that question and answer.
And I will also point out that sometimes there's a power issue on the ISS and the LIS isn't functioning. So for much of September and part of October, that was the case. So you would go to that website and not see anything because I don't know how the ISS has a power issue that turns off one of their instruments, but apparently it does happen. So.
Mm-hmm. Good and useful information. We're finding all sorts of interesting features of both the NOAA and non-NOAA satellite data as we explore commercial options. For example, finding out that even generally high availability data sometimes has its limitations, which underscores the importance of working in a multi-sensor environment. Let's see, Mike Jammer asks a question of Chris, are you doing lightning related work at sport? And if so, what kinds?
Yeah, hey there. Hey, thanks for the question. I actually just answered real quickly in chat, but I probably can't go into a lot of detail, but anyway, there are some projects that we're currently working on with regards to lightning prediction and lightning safety. One of those is a relatively simple project. The others get a little more sophisticated, but one of those projects, hopefully, at least I got Scott word the other day, will be presenting at AMS along with Kelly Murphy at Sport, and then there'll be some other products that will be out rolling for some testing and evaluation, probably next spring. So if you're interested, you can email me and we can keep in touch about those sorts of things, and I'll put my email right there in the chat.
All right, thanks, Chris, and thanks, Mike, for the question. Another question, is there anyone aware, any of the speakers or anyone else in the audience aware of any plans to fly an LIS-like instrument beyond those that already on the ISS? Or is this, as of now, kind of a one-shot deal?
Yeah, again, this is probably a question for Steve. I would say this is a one-shot deal, and it's always, I mean, the challenge is a lot of people want to put an instrument on the ISS. So keeping the LIS up there for so long has been quite an accomplishment, I think. And I'm not sure how long it's going to continue.
Yeah, thanks, Scott. I was also wondering maybe if it was potentially a pathfinder for a follow-on on a satellite mission, but perhaps not.
Steve Goodman question.
Mm-hmm. Yep. We still have a few minutes, so welcome additional comments or questions in the chat. While we're hanging on waiting for those, just a comment from here. We understand that sometimes configuring AWIPS for a data set that it's sometimes hard to time that to have that lucky coincidence where you have a polar flyover at the right place at the right time, so it contributes to the real-time mission. But we are interested in hearing sites that are interested in trying this out and what result they find. We can certainly also see the value of these data in terms of intercomparison with other data types, validation and after incident reporting where maybe there's a confirmation needed of lightning, and particularly in those cases where the Earth's network or the GLM doesn't necessarily perform that well. Okay, and was that a new question coming in or maybe just a comment? Mike, I see a question for Lee. Is that an incoming question for us?
Hi, yeah, can you hear me?
We sure can.
Yes. Okay, good. I had a question for Lee Byerly. I know there's two Lees here. So Lee, just curious, with the ingest of the data utilizing the DMW plugin, I recall that at least with our try with the GeoCloud or GeoPrime ingest, that it turned out that config utilized the same domain config for the DMW that we had set locally, and so we had realized that we actually had significantly cropped the data to the same domain that we were cropping the DMWs. Is that going to be the same possible issue? If yeah.
Yeah. Hey, Mike. Yeah, that's a good question. I was thinking about that because you would have to rely upon whatever that plugin filter setting is, and that would curtail your ISS Lightning OBS that are going to process. So it's actually a good thing, right? Because global, maybe you wouldn't want the global ingest unless doing a research project or something. You'd want to kind of tailor that down. So it would definitely apply the same type of filtering as we saw for that other work.
Yeah. Okay, good. Just curious. Thought I'd throw that out there. Thanks, Lee.
Okay, thanks.
Thanks, Mike. Thanks, Lee. And we have another question in from Mike Jammer. Can one of you discuss the advantages of lightning OBS from above versus or complementary to ground-based networks?
Hi.
Yeah.
I guess unless Chris wants to take this one.
Well, just I could say one thing that immediately came to mind, Scott, is that typically you're going to observe lightning flashes from above or just in cloud is going to occur typically before cloud to ground. So it may give you 5 to 10 minutes or so. So that's one advantage of just viewing lightning in that regard, whether it's from an LMA, which is actually a ground-based network, or whether it's from space, the ISS or GOES.
Thanks. Yeah, I won't add to that.
And also looking at it from above, you're going to get the extent. I mean, you're going to see lightning in the other parts of the storm system, the cloud that is not striking the ground. And then by ground network, you mean just something like NLDN or Vice, or the VISLA or the NTLN data. You might not get really the extent of the lightning that's going on within a storm. And so what other, could there be other cloud to ground strikes that could occur a little bit more distant from maybe the storm centroid? So that's just immediately some advantages I could think of.
And a response to my questions in the chat, yep, all ground-based networks are less sensitive over the oceans. ISS LIS doesn't have that problem. Okay. All right, I've got just a couple of minutes if there are any final questions. We'll hold on just. Go ahead, Chris.
I have a maybe more of a comment, but I don't think, someone wants to correct me, that's fine. I don't think that any of the data right now are flowing through any weather service LDMs in any of the regions. they're certainly not through southern region. I am trying to bring in the data right now as a test through my own cloud instance, and Lee Krantz and I are working on that. Having some issues. In fact, we're getting on a call this afternoon to see if we can resolve why I'm not processing the data on my cloud instance. But nevertheless, once we get that figured out, then we'll maybe have, if we figure out there's some sort of an issue, we'll have some revised instructions if people want to bring the data in that way. You know, some regions are different in the way they deal with data through the LDM. It might be more locked down in some regards than other regions, but we can have some instructions for at least people that want to bring those in through a cloud instance if they want to do that.
And I can just add to that, saying that the data themselves over the LDM are coming from the experimental feed from NSSTC, UAH, and so this is not like a NOAA-wide kind of feed or anything like that. So you would have to go through your regional headquarters to make that contact to NSSTC in order to get a particular data feed that's above and beyond kind of like what NOAA port supports and things of that sort.
All right then, I think we're coming up to the end of the session, and if there are no further questions, we wanted to thank all of you for your participation. Thanks in particular to the speakers, Scott, Lee, Chris, thank you very much as well. Thanks to Steve Goodman in the air, but for all his work on this, both GLM and more recently his encouragement of LIS. We'll forward those questions to him and try to get the answers out in the session once it's posted. And with that, I think we're ready to wrap it up for today. We wanted to remind you again that the lightning theme continues a week from today with Gabrielle Brown's talk on the GLM trends associated with tornadoes in landfalling tropical cyclones. So look forward to hearing that a week from today. Thanks to the speakers, thanks to you participants. Great talk today, and this will be posted in the not too distant future. And we look forward to seeing you next time.